I brought my equipment outside today because I want to do an experiment for you that were we to do it in the lab would be a little dangerous. Had you been doing this, we would have had to go into the fume hoods to do all the work. I'm going to start off with a chemical called potassium chlorate, and I'll put the label out here for you. It's a compound that has lots of oxygen in it. And what I did just a little bit ago was I massed out 3 grams of the compound. It's a white powder, and I'm going to put it into a special test tube here. This is a very strong glass test tube. It's called an ignition tube, a little thicker glass. We'll dump our powder into it. I have measured out and massed out 3 grams of the potassium chlorate. You can see it at the bottom there. Let me clamp this up now. I have a clamp with a rotatable position. Okay, it's flexible. I can move it. So now I have the potassium chlorate in position, and what I next want to do is heat it up. And I'm out here in the plaza, so there's no gas around, so I have to use a propane tank of fuel, which looks like a little torch. In fact, is a little torch. And what I'll do is I'll heat this up gently and hopefully get the potassium chlorate to melt. Now, this is pretty reactive stuff, so I'm going to put it aside. I'll put it on one of the little benches here, then I'll come back. So let's light up our torch. We have a little bit of a wind today. So our torch is running. I'll bring it around to this side, warm up the test tube. I'm going to warm it up a little bit gently on the first try here. What will eventually happen is that the potassium chlorate, once it starts to get hot, it will start to melt. And when it starts to melt, it actually starts to decompose. Whoops, we've lost our flame. Let's try that again. We have a lot of wind. Temperature of the torch can get beyond 500 degrees Celsius, so it warms it up pretty quickly. And in addition to the potassium chlorate, which when it decomposes gives off lots of oxygen, I have a piece of Jolly Rancher candy here, and I'm going to put this piece of candy into the tube when I get all the powder melted. So it's starting to liquefy. Let me go around to the other side here. It's melting very nicely. It's a little puddle in the bottom. I'll turn off my blowtorch. And with the molten potassium chlorate, let's now drop in the piece of candy. Goes all the way to the bottom. Alright, that reacted very well. A good bit of smoke that came out of it, and the smoke has gone away from me from the direction of the wind. So I'm going to move around just a little bit with my computer here so you can see the test tube a little bit better. At the bottom of the test tube, it's all black. There is a material on the inside which is pretty much mostly the unburned carbon. And what I want to try to do is be able to get the compound out of the inside of the test tube. It turns out to be a product that I can actually dissolve in water, and then from there what I'll try to do is clean it up and filter it. And all of this begins to bring into play the information that's in chapter number 12. And the topic that we're dealing with is a topic called stoichiometry, where we take a measured amount of material, we react it, and we figure out how much measured product we could get, and then how much do we actually get. So I'm going to pause the video here, move inside, and show you the next phase where I clean up the residue that's on the inside of the test tube. Now we're back in the lab, and I have the ability here to heat things using the Bunsen burner. My test tube at this point is cool enough for me to touch it. I want to bring it up a little closer so that you can see that there are some residue on the inside. Some of it is dark, brown, black, and some of it is white. The material that's white is called potassium chloride. And I'm going to turn my computer around just a little bit so you can see the board. I'm going to write the chemical reaction that we've just done on the board. So my reaction is now started with potassium chloride, KCLO3. I have that on the board. When I heat it and it breaks down, it produces oxygen gas, O2, and the residue, the white material that you see in the test tube, is KCl, potassium chloride. There's a lot of oxygen that's given off, and with that little piece of candy that I had, there's plenty of oxygen for it to begin to combust. And this material here is decomposing. The following reaction, once it reacts with the piece of candy, is actually a combustion. So a little piece of candy, any type of candy that has sugar in it, good fuel, it will release lots of energy. When you eat the piece of candy, you're going to get the same amount of energy out of it, but it won't be as fast as what we saw outside. It's going to be a lot slower because your body releases the energy from it at a much slower pace, and it's a reason why we keep the oxidizer away from the fuel. So the candy and potassium chloride, they are actually stored at separate spots in our storeroom. We don't want to put them side by side, just in case something would happen where they combine. Now, the next thing I want to do, taking my test tube, I'm going to add some tap water to it, which I've poured into my test tube here. I'm going to add all the way up to about 3/4 of the test tube, up to about where the clamp is. And then I'm going to heat it with the Bunsen burner to get some of the material on the inside to dissolve. So I have my Bunsen burner here. Let me turn on the gas. Our burner flame is working. I'm now going to take my test tube and I'm going to point it away from me, and I'm going to heat it gently towards the bottom and try to get all the material on the inside to dissolve. And what will probably eventually happen is the water on the inside will start to bubble, it will start to heat up and boil. Let me try it from this side now. I wouldn't want to put this near my face because there is from time to time a tendency for the liquid on the inside to boil real fast. And if that were to occur, the contents could come shooting out. So if you were doing this in the lab yourself, you wouldn't be pointing it at yourself or your lab partner. You'd keep it safely directed in a way that they would not be affected by it. So it's starting to loosen the material up on the inside, and I'm getting bubbles at the top, actually a little bit of foam. And I can actually feel a vibration in the tube as the material starts to dissolve. The vibration I'm feeling is from the bubbles of the water that are being produced. You might be able to see a little bit of steam coming out the top. Okay, and now what I want to do, I'm going to turn off my gas, let this cool for just a little bit, and then we'll begin the process of filtering it. So we'll put that into our rack. I'm going to dump it into my beaker of liquid here. And on the inside of the test tube, I have a black residue, but potassium chloride that was on the inside has pretty much dissolved. So I'll just put that on the tabletop here to cool down. But here's the stuff that we want to test further. This has dissolved in it potassium chloride. I can't see it because of all the black and the dark stuff, but what I can do is try to clean it up. And what I'm going to actually add to it is even darker and blacker. It's called activated charcoal. And I'll put a spoonful in. That's what it looks like. If I get it on me, is there going to be a problem? No. With my clothes? No. So now stirring the activated carbon into the beaker of the potassium chloride and the brown or carbon-like particles on the inside. I got a little bit on my fingers, but I'll just wash it off. It's not a harmful material. In some ways, it's useful to us to absorb colors and odors. And I remember years ago, they used to put it into the filters on cigarettes to absorb some of the products that were coming through in the smoke. Now, I'm going to stop the video for just a second, come back, and do the filtration. Although what I just did in terms of cleaning up a little bit took about a minute, I want to show you the process of filtration. Here's our beaker with the liquid in it with potassium chloride. To do my filtration, I'm taking a piece of filter paper. I'm going to fold it in half, and you got a semicircle. I'm going to fold it in quarters. Then I'm going to pull 3 sides away from one, and it forms a cone. I'll put that into my funnel. My funnel is sitting over a beaker. Let me tilt this a little bit more. And it's now begin to pour our liquid in. I don't want to fill it all the way to the top, because sometimes what happens is it overfills, it spills over. But I want to collect the solution that's coming through. And the solution has potassium chloride in it. And potassium chloride in water is colorless. And I'm going to try to get this up a little closer for you. And I'm not sure if you can see. Let me put something white under here. Here's my beaker. And the liquid coming through has a very, very slight color to it. And it's very slowly leaking through. What I would do is at this point let it filter all the way through, and then I'm going to catch this liquid and dry it out. Eventually what I'll do is I'll weigh that, and I'll be able to give you the data on that in a class. But just to show you what's happened with the process. Now I'm going to stop the video at this point and then probably put more information up on a video for you.